So today's lab is Investigation 3, Physical Properties. Starts on page 22, and it reads in the introduction. In this investigation, you will measure the weights and volumes of 3 metals and 1 liquid. The volumes of the solids will be obtained by putting them in water and measuring the volume of water displaced or pushed out of the way. That's what we have the 25 milliliter graduated cylinder for over there. This is a convenient method for determining the volume of an irregularly shaped object. Why is it that the water displacement method cannot be used to find the volume of some substances? I think that's a rhetorical question, but that's a pretty easy one to answer.
Then it wouldn't be rhetorical, would it?
No, it's rhetorical if you don't bother with answering it. Oh. So anyway.
This whole book is rhetorical then.
Later. Step 1 says obtain samples of lead, zinc, and aluminum, and then we're going to compute the average weight of each sample and record the weights in the appropriate spaces below. Now what we did in prep for the lab, there are 3 little beakers, because we can't just take the chemicals out and stick them on the scale. If we did that, they'd roll off, and that's a problem. So what we've got is 3 little beakers that David has the weights for. One of them's numbered number 1, one's numbered number 2, one's number 3. Okay? So the first sample we're going to do is lead, because it's the first one in the list. So grab beaker number 1 and stick it up on the scale. Thank you. Okay, now grab the lead. Yep, that's the lead. If the lead explodes, you're really doing something wrong. Okay, now very carefully, because they're tiny little lead balls, it's lead shot. They roll a lot.
I could have brought you a lead shot.
I'm glad you could have. This is pure. Okay, so very carefully get some of it out. That doesn't mean reach in with your finger. We've got a scoop. And you need to go straight from there into the beaker so we don't lose any of it. And you actually have to get some on the scoop. I see, I told you, very carefully.
Dude, this is, you gotta be kidding me.
It's like a carnival game.
I'm like a... It is a carnival, dude.
You just dump some in there, like, forget the scoop.
Just don't miss. There, that's getting better. You can do a little more if you want.
Awesome, I'm gonna do a lot more.
Because I'm going to reuse this chemical tomorrow, so. Okay, good. Go ahead and seal that up so we don't get it contaminated. So that's a lot of lead. Alright, now, find the mass of it. So balance the scale. And then once we've got it balanced, David's going to give us the number we need to subtract to get out the beaker weight.
Alright.
Just like you're doing.
This is kind of
Just make sure it's in the little groove. There you go.
process. I feel like I'm taking time.
You're doing good.
Can I touch this end? There we go. Is that good?
Is that even? It looks like it's
Is
a
that a
little low.
rhetorical question?
No, it's not a rhetorical question because it looks like it's a little low. Let's ask the audience at home. Is that even? No, it's not. Better.
There.
There you go. Okay, so that mass is the hundreds on the 0, 40, and then
40 and
It's just below the 6?
6.9.
okay. So 46.9 is for lead. What I would do is right there in the very top line for lead. Okay, and then below that, bless you, below that you're going to write the number that David's going to give us for the lead beaker.
29.1.
Okay, so below that write 29.1, and then subtract. So the top number is 46.9, then 29.1. Subtract those two, and you'll get the weight of the lead, which is
Dude, I haven't
17.8.
done subtraction since like third
Yeah, that's
grade.
what I get.
I don't even remember how.
Okay, so the weight or the mass of the lead you have is 17.8 grams. So now we can put that to the side. We can go ahead and do the same process for substance number 2, which is going to be zinc. So
Is that it?
that's the beaker number 2. And as we look in at the zinc, we notice this is the irregularly shaped object it was discussing.
Smells gnarly.
Don't smell it.
Oh, well, too late.
I thought that was why we went over that in the lab safety video, wasn't it?
Dude, that whole thing, as you would say, was rhetorical. Can I touch this?
A little late, isn't it? Just go ahead and put it in there. Just don't touch what's left in the beaker or in the container. Okay. Does somebody else want to
DJ?
do the scale?
What?
Since he did the
DJ
first
can do
one,
the scales.
somebody else can do the scale.
You're gonna have to go that way. Other way.
Yeah.
This has to go up.
Forget.
Definitely different. Ah. Well, I guess DJ's not doing it anymore.
DJ takes too long. I don't like inefficiency.
It doesn't like you.
Good. You can die in a ditch.
Okay, so for the zinc, looks like 34 point.
Wait for it. Gorgeous.
It's a little bit past the halfway mark, so maybe 34.55. Okay, so write that on the top line of the zinc. Okay, and then, David, what's the number we're subtracting from that one?
29.
29 even?
Yep.
Okay. So that's going to be 5.55? No, yes.
Yep.
5.55. Okay.
Basic formatting.
And so now we get to do the same thing with the aluminum. So grab number 3.
Where is it? Can't see.
How many?
You can do more than that if you want.
There's only a handful more. There you go.
Okay, that's good.
Get you some.
Oh, that's close. Did you get exactly 40? Or are you that? Not with a fly sitting on there.
Wait. Yeah. So
Okay,
40.
so 40.05. That's pretty stinking close to 40. So 40.05,
My eyes itch now.
that's not fun. 40.05 is the mass with the beaker. And David, what's the mass of the beaker?
28.9.
28.9. 11.15 is the mass of the aluminum. Alright, so now look at step 11.15. So now we look at step number 2. Step number 2 says, determine the volume of each sample separately as follows. You're going to fill a 25 milliliter graduated cylinder to the 10 milliliter mark. Liquid levels should be read from the bottom of the dip, or the meniscus, which it shows over here in the diagram to the side. Okay, and then you're going to carefully add one of the samples of metal to the graduated cylinder and make sure there's no air bubbles trapped on the metal. So, you don't need to use distilled water for this. You can use the big one, but we need to use the 25 milliliter one, which is the one that he has. Okay, so very carefully fill it to exactly 10 milliliters.
Oops.
Whoa, no, it's water. What are we going to do with it?
Dump it out.
Should we have our goggles on for this?
I don't know, maybe. Let's turn it on. Yeah, there you go.
Yep. have to set it
I know. But there's a bubble in there.
That is pretty darn close to 10, as far as I can tell. You think so?
It's a little over.
No, because you read from the bottom of the bubble.
It's a little over.
Uh-uh. Not when you're at eye level. It's not.
It looks over from here too, but it's
It looks
But
over.
you're also above it.
yeah.
Get down to that level. It's perfect.
It's
It's perfect.
alright.
Okay. So,
Don't throw hydro.
which one are we gonna do first? I'd say-
funky
This
looking
one,
one.
because this one does something actually.
If any of them do anything with the water, then we've got problems. So,
Didn't that do something before?
Dude, that was with
no, it was with hydrochloric acid.
acid.
We are not mixing it with hydrochloric acid because I did not enjoy almost dying. Okay, so we're doing aluminum first because that's what they picked. So it says very carefully add it because you don't want any air bubbles trapped in the bottom.
All of them? Or just one?
All of them.
Oh,
And they all have to end up underneath, submerged underneath 10 milliliters of water. So this may not work because you may have used too many.
nope, we got this.
Are they all under the water?
As far as I can tell.
Okay, so
So it's like
read the volume.
right at 9:19, maybe. Is that 10 right there? Because I don't want to count. That takes too much time.
Well, see, it's
inefficient.
numbered. That's a 15.
Oh.
So
you're
each one of
right.
the big lines is 1, and it is just below the halfway of 14. So maybe 14.2. So there you go. 14.2 is your volume for aluminum. You're going to write that over here under aluminum. Okay, but you look at what it says to do in step C. Find the sample volume by subtracting the final level of liquid from the initial liquid level. So what was your initial liquid level? 10 milliliters. So 14.2 minus 10 is
4.2.
4.2. So go ahead and do that. 4.2 is actually the number that you need. Okay, now we're done with this. Make sure we got them all out. Nope. There we go. Okay, so fill it up again to 10. Exactly 10.
Do we get to boil this?
Now,
Can I eat one of these?
do you want to die?
Maybe. The seminar was pretty depressing.
I didn't think it was depressing at all.
I thought it was pretty depressing.
Uh,
Especially when he was in the hospital, dude. This made me...
is that it?
For assurance or something?
Do I need to look at it too?
Yeah, sure.
You looked at Jared, he's like,
What do you think?
Oh, it's only so slightly above it. But you know what? I think it's close enough. Because it'd be pretty difficult to get it lower than that. Okay, so it's like a tenth of a milliliter off. So if we want to subtract a tenth of a milliliter, we can't. I just leave it on. Okay, so which one are we doing next? Zinc?
Sure.
Or, as Jared said, the funky looking one?
Funky.
Don't lose any. Did you get them all in there?
As far as I can tell.
Okay. Tap it a little bit, make sure there's no air bubbles trapped underneath it. There you go. Okay, so read the volume. Do you want someone else to read the volume?
Yeah, I'm not good with numbers. Give this one.
I didn't raise that much. I know that.
You guys are killing me. If I weren't in a hurry, I wouldn't be doing
you
it.
should make Trey do this. He hasn't been here in about.
That's what I'm thinking. Okay, Trey. What's that reading at?
Looks like,
There's 10.
looks like it went up about 3 lines.
Yeah, if you read it from the bottom, though, it looks like the bottom's right at 11.
Oh,
Okay. So it's at 11? Or was it 10? So what does that make it? 10 minus 11 is 1.
This is zinc.
Yeah, it's zinc. Okay, and the last one, the lead.